Okay, here we go. Today is the day. Hello and welcome to a Rust tutorial. Yes, we're gonna talk Rust today. This is gonna be an introduction to Rust for Solana developers. So I'm expecting that you're already familiar with another programming language. Most Solana devs usually start out doing some TypeScript stuff. So this is the language that I'm gonna compare with. But I guess for following along, it's fine if you have some background in C, C++, Java, JavaScript, TypeScript, any of those really. They're all relatively similar. But I wanna talk you through what's different in Rust, such that you can follow along in my videos when we do Rust development. And again, this is just gonna be the basics to get you quick started, and you can do your own research then afterwards and dive in deeper, start developing and then you'll figure it out. The cool thing about Rust, the compiler gives you really nice error messages and makes really helpful suggestions. We're gonna go through syntax, we're gonna go through some things that are specific to Rust, and then we're gonna end up with the borrow checker, which is probably the most important thing for you to understand to be able to properly develop in Rust and not get super confused, because most of the rest is pretty similar to other languages. I'll try to get through this relatively quickly, but it's quite a lot of content, so let's just get started. Okay, I'm gonna assume that you have Rust installed. If you don't, I have a video on how to install all the Solana stuff, Rust included. So we can use Cargo to create a project. Cargo is basically the package manager, just that in Rust we'll have crates, not packages, and we'll have this cargo toml that defines stuff about our project. Let's call it Rust basics, and we'll have this main file. And the first thing I want to note here is Rust is a compiled language, not an interpreted one. So in order to run this, we will first need to compile the code to get an executable. We can do this with cargo build, and we build our Rust basics, and we get this target debug Rust basics. This thing is what we can run. Target debug Rust basics. Boom. So that's the executable then. So far, so simple. So let's have a look at syntax, because it's not too different to what you're used to from other languages. You can define a variable with let and give it a value, and it will automatically infer the type. You can define the type, much like in TypeScript, by saying, oh, this should be a U32, an unsigned integer. With the double point, we always define the type. This variable is not mutable though, so if we want to change the value of it, this won't be possible. And if we want that to be possible, we need to specify that it should be mutable. Then that is allowed. So that's a variable, nothing super new here, except for, how to define it mutably. The one thing that often throws me off, especially when I switch between languages, is that in Rust, if you have an if statement, that part does not come in braces. If I have an expression here, variable equals 3, that stuff doesn't go in those brackets as in other languages. Rust does not want them. This is wrong syntax in Rust. And if we try to build this, then we will get this warning, unnecessary parentheses. That's what they are called. And Rust will even give me that note, remove them. Okay, let's remove them. And that's for all of them, not just ifs, but also if we have a for loop or a while, something like that. And then in the end, let's print our variable. And you see the Rust compiler is fairly smart. It understands that this one is never read before it's overwritten here. So we get another warning that we can get rid of, and now it builds. Okay, so we don't need parentheses here. That was my point. Still talking about syntax. You might be used to this formatting. I just say, hey, take, I can say variable this, and then here. That's just a format string. You're probably used to that as well. So if I build this and run this, we'll see the variable is 3 because we count up as long as it's less than 3. So far, so easy. That's just some syntax, and the Rust analyzer underlines it because it's mutable. Next, let's look at functions. How do we define a function? We say visibility, fn for function, and then function name. Oh, by the way, in Rust we use this, what's it called, snake case, and not camel case. Yeah, snake case. That's just a convention. But it's a convention that we want to stick to, because otherwise we get shamed by Rust devs or something. I don't know. So that's the function name. Then the function arguments. Argument 1. And you can type them, say this is a U32. Argument 2, that's a U8, whatever. And you can define the return type of a function, but not like in TypeScript with the double point, but you would do that with this arrow and say, oh, this returns a U32. And if I do that and I don't return anything, then of course it complains. So I gotta return a U32, like 32. It's a valid U32. And then it complains that I'm not using the arguments. This would just be warnings. Okay, fine. Use the argument plus the other argument. And then it will complain again that this is a U8 and this is a U32. So as U32, that will be fine. I can just cast it because a U8 I can always cast to U32. That will be just fine because U8 is smaller. So there's this basically a sum function here now. And I can call it from somewhere by doing my function name with variable. And let's do 3 plus 4. And this result should then be 7. Let's build, run. Result is 7. Easy. My point here basically just being this is the syntax for defining the return type and this is how you return. However, and now we come to the next very important difference between Rust and TypeScript. In TypeScript, those semicolons don't really matter. Like if I were to not write this semicolon here, then TypeScript would just be fine. But in Rust, we need them because they mean something. And what they mean is that if I don't write it, then basically this is being returned. So let's go back. This here is actually the same as this. That looks a bit complicated. Let's step back. Hold on. Let's first save that result in here and return the result. That should make it more obvious. Now, this line is the same as just writing result without the semicolon. Now, if I don't have that, I just write result. Result is being returned because there is no semicolon. So if we build that, run that, the result will also be 7. Or whatever I return here. I can return 42 here. If I build that and run that, then the result is 42. So this thing here, because there is no semicolon, it is being returned. If I have the semicolon, then it complains, oh, it doesn't have a return now. So yeah, point being, this is the same as this. At least here, in this case, it's the same because return will always return on function level and we are returning on function level here. It is a difference though, if we are somewhere else in the code, because, and let's get this, also statements like the if or the while can return something. And that might be counterintuitive as well if you come from other languages that don't allow that. In here, for instance, I could say, I don't know, 42 here. Then that 42, I could save into this variable. However, what it's complaining now is, well, in this case, we suddenly have a return value if the variable is 3. So else, we must also have a return value of the same kind. If I say here 43, then I'm fine. And important now though, since this is such an expression, we are not returning the number. Now we need that semicolon here after this if. Unless we wanted to return this. Maybe let's go back down to our function. We could say if result larger than 10, we return 10, else result. And then we return whatever comes back from here. So now it's a sum with a max of 10. Oh, and again, I'm always making those mistakes with the brackets because I'm just so used to them, the parentheses, but I don't need them. So if we compile this, what's the result gonna be? We have still 3 plus 4 is 7, so we expect the result to be 7 still. But if we were to say 3 plus 100 and we build and run this, then the result will be 10 because now we're in this branch of this condition. And the result of this is being returned here. And that might, be counterintuitive to you. If you just look at this function, it might not look like that returns anything, but yes, it does because there are no semicolons here. in that case, you know, it expects something as a return, and there's also no semicolon here. And then again, it expects something to be returned. If there are no semicolons, then it will return that. And again, it must be of the same type. So I can't have, you know, no return up here, but then return the correct thing down there. Or, I don't know, return a slice or anything. This will not have the correct return type. The string will not be a U32. So it must be of the correct type. Yeah, that's return types and why those semicolons are important. They do mean something in Rust. Okay, cool. That's one important aspect that you need to understand to read and write Rust code correctly. You can also return something out of a loop, and in Rust we can loop with loop. That's basically a while true, so we just constantly loop there until we break, and we could, you know, conditional whatever, and from within the loop we can break. That will then, you know, stop the loop and continue. But also a loop can have a result. Look, Rust is smart. Since we are not having the semicolon here, if we have the semicolon here, then that part is fine, but we're still missing the return. If we want to return what the loop has as the result, then we need to specify it here at the break. And that might also be new for you. It was for me. I can say break a leg and let my leg be what I get from this if. How about that? And then we can break a leg because we can. And then it has the correct return type because this is of the correct type. It's a U32. And when we break with that value, it gets like same as loop result is this. I could, you know, save this and then return the loop result. Or I don't save this and I just remove this semicolon. Same. Right? And of course, in your loop, you can have other things. And that also works with a while. While loops evaluate to unit types. Okay, it does not work with a while. I just learned something. I can't do that with a while. I can only regularly break. But with a loop, I can break with a value. Okay, cool. I learned something. And the reason I didn't know that is because I never use that. You know, I don't usually need that. What else? I think that covers most of what I wanted to talk about in terms of syntax. Let's talk about some common types that we use a lot in Rust. One of them is an option. And the option will have an inner type, in this case U32. So what that means, an option is either sum with the type, so in this case a U32, I don't know, a number, or none. Those are the two types that basically makes an option. We use that for when we, you know, have an optional value or like something that could be undefined or null. In Rust, we just like to use this option and then say none if it's not present or some if it is present. So in this example, if we now return an option of U32, we can say, well, if the result is larger than 10, let's say none, and only if it's smaller should it have some, and we return that and we ignore this loop. That would be valid. So we only want the result if it's less than or equal to 10. As soon as it's bigger, we say none. This doesn't work, this shouldn't work, whatever it is, right? So then we get none. And to properly display this, I need to tell you, that's also a neat little trick. This will make it so that it uses the display, and I think this will make it debug as well. In this case, it's the same, just depends what option has implemented. There are implementations, for instance, the debug, if it implements that, then can do this. But I can also just use the display, it will also work. So in this case, our result is none. Why? Well, because it's bigger than 10. If I were to go down to 7, then I will have some 7. So this result is now an option. And to get out the value of this option, we can say unwrap. This gets out the value from this option, resulting in the actual U32. So in this case, the actual number 7. However, this will panic when we don't have a sum, but we have none. For instance, if I have over 10 again, let's do it all together. Cargo, build, and execute. There we go. Thread main panicked at line 18 here, 37. option unwrap on a none value. So panic is if the program doesn't know how to continue from here, then it will just stop. So we can't unwrap a none, obviously. Another way to unwrap would be to say expect, which is basically an unwrap, but we can provide a message, result was none, something like that. And if I run this, I will also panic, but instead of this generic message, we get our message, result was none. So you might want to use that instead. But really, what you really might want to do is check if we have a result. So if is sum, then do this stuff. And here we know that it is sum, so we can for sure unwrap. And else we say result is none. This might be what we want to do. And then we get result is none. You can also do that with a match. So instead of this if else, you can also do match the result. And now we need to specify the two branches. If it's sum, what do we call the inner? Just call it lowercase r. That's the actual value inside then. Oh, and I always get that wrong. In the match, it's the equals error. And then result is r. And for the match, we always need to specify all of the possible branches. So if it's not sum, then it is none. And if it is none, then we basically print this. And that's the same as this. Might look a bit nicer, I don't know, up to you. But it will print the same. In this case, it's none. And if it is 7, then it's 7. Yeah, this match, as I said, it must have all possible paths. So I could match on a number, I could match on the variable, for instance, and I could be like, if it's 0, then 0. But it won't be happy because it needs all paths. And since I won't be able to do all of them, I can use this underscore to say any other number. And in our case, it's 3, so it will print that. If it was higher, then it would be any other number that we defined here, the path of the match we define here. And if you need something bigger, you can, of course, also put that into a block and do, I don't know, your whatever calculations in here. Variable is now 0. Then print this, and then, and so on and so on and so on. I think you get the idea. And also here we can have return values, right? Here we're just printing stuff, but also from the match we can return something. It just, again, needs to be the same in all of them. So let's say 0 or 1. If it is sum, I want to return 1, but then I need to put that in curly brackets here. And if it is none, I want to return 0. Again, need to put that into curly brackets. And then I have either 0 or 1 in this variable. And I can put the 0 or 1 here. And what are we gonna get? Any other number, because it's 1. Look, 1. Because we have some. Can you follow so far? It's this all not particularly difficult stuff, just some syntax that you need to get used to, and getting used to that all of those can again result in something, and that semicolon is important, and match must have all the possible paths. But yeah, then you can match anything. And one more time here, because this is also something that is not super easy to grasp in the beginning. We say match result, and this is what we're matching for. We're matching for some R. And this R is anything we define, any variable name for the inner value, you know? Then here in this block, we can use that, any variable name for the We basically just define, if it is sum, then put the inner thing in here. If I don't need that, I can say sum and underscore, then I can't access it here, obviously. I mean, I would again need to result unwrap, which is, you know, not nice, but it would also work because now we're using this again. But the cleaner way or the nicer way to also in here, when we already check for the sum, we might as well get the inner thing that I called R and then use the value of this here. Yeah, does that make sense? Cool. I think that's me done talking about the type of option. I think I'm happy with that. Let's talk about another type that is very common, and that's a result. A result, similar to an option, it either has the result or not, but in the case of not, it will give you an error. So a result is always either an okay or an error. It's either of type okay something or error something. And the types of the errors and the okays we can also define in here, where we say result. So either if it's okay, we expect a U32, and otherwise we expect as the error an IO error, a format error, whatever kind of an error. We can define the type here. We can even say, oh, we want an error code, say a U8 represents the error. But usually you'll have a typed error. But for now, let's do this U8. So either we return okay with the result, or we say error. And now we need a U8 error code. I don't know. My error code is now freaking 66. I don't care. So that's the type that goes here. That's the type that goes here. Result is always either an error or an okay. And then, you know, we can play the same game. We don't have an option here anymore, so it's not sum. If it is okay, then we do this, else we do this. And the unwrap is the same. I also unwrap the result to get the okay part. And the match, to match the result, again, same thing, okay or error. And here it has the code, for instance. Result is error. Can write the code here. There you go. So that works the exact same. Change that value to get an error. Then result is error 66, because that's what we wrote in here. And here we unwrap it into this code. Well, unwrap from the result, error will give me an optional error. So if there's an error, then we get an option of sum. We can expect error to get the E, or we can expect to get the okay value. But this will panic if there's an error, and this will panic if there's okay. And unwrap error will again give us the error and panic if it's okay, and unwrap will give us the okay, the inner value, and panic if there's an error. Since those two always panic, there is other ones that we can use instead. So we could, for instance, say unwrap or default. So if there's an error, we use the default value, which for U32 would be 0. Or I can say unwrap or else. So either the unwrap works or, and then I specify a function returns the okay value or computes it from a closure. So here we give it a closure. Is it already time to talk about closures? Since we're here, yeah, why not? Here we basically define a function that should then compute the thing. And we can do that either like this with a proper function, or in the shortcut way written like this. What the function receives is the unwrapped error. So unwrap will give me the okay value. Then if we get the okay, then we're fine. But if we get the error, then in here we get in our case, we have the code. So the error code. See, it's a U8 because that's how we defined our result. The error part is the U8. And that's just syntax. You know, in TypeScript, you would have that with like parentheses and then the arrow. In Rust, it's just those straight lines. I don't even know what they're called. And then I can use the code and work with it here. Error code. Let's just return the code as a U32. Now look at this and tell me that you understand. Because that has a lot of, you know, Rust specificity to it. If you don't understand, don't worry. I'll put that at the end and get the value from result as a U32 here, and then print that. What's your guess? Whoops. If we have this error 66, what's your guess what the value from result is going to be? 66, because we get the code as U32. If we don't get an error, then we get the proper result. So in this case, now it was the normal unwrap. Now it was the same as if we just do a regular unwrap. So far you should be able to follow, right? We just result, unwrap, and that's the value from the result. That's what we print. That's the 7. If we get the error again, just the unwrap would panic. And it would panic because we called the unwrap on an error with value 66. So we say, instead of letting it panic, we say unwrap or else. so that's the else in case of error, get the type of the error, like in our case it's a U8, our error code, so that's the 66, and then basically we just return the 66. So that's the same as if I have a function get code from code U8 that returns a U32, and what it does, it returns code as U32. That's the long way, and then I would put this here, boom. That's the same, that's the exact same, but that's the long way of writing it. The short way of writing it is with those 2 bars. So that is this, and that is this. And again, here I don't need the return, I can just write it like this, same. And I don't even need this whole function. I write it in this quick little closure here. Can you still follow? So that's the unwrap or else. There's also the unwrap or. With the else we define a function what to do, and with the unwrap or we define another value. So 0, for instance. Our default value shall be 0. We unwrap, we get the value for okay, and if it's error, then we say use 0. Could have done that before as a step before. Yeah, so now the result is 0. But I like the unwrap or else, because then I can also work with the error. Obviously, it depends what you need, but yeah, just so you've seen those closures as well. And all of that, you know, often I prefer working with those closures versus a match. I can of course also do it with the match. I match the result, say if it's okay, if it's error, do this, do that, da da da. Also return the whatever. You know, the exact same thing as I'm doing here with a unwrap or else, I could do with this match, where I say if it's okay, then unwrap, so give me the R, and if it's the error, give me the code as U32. This here is the same as that. I could not do this and put the value from result from this match. Also works. It's pretty much the same, just that I kind of prefer those closures because they're, you know, that's kind of more functional development that I kind of like, because then on this you do that, and then on, and so on and so on and so on. It's kind of, it just to me looks more straightforward. But of course it works with a match as well. Again, that's the exact same code. There we get the 66, and if we use that instead of that, we'll also get the 66. Yeah, cool. What else did I want to talk about? Check my notes. I mean, I like this functional style here because it allows me to do fun things like mapping stuff. Map error, map or. You might already be familiar with this. When we put for a value another value, you know, we basically map stuff. For this, do that, did that. For instance, let's do map error. If it's okay, then it will just push through the okay value. So it maps okay to okay, 1 to 1. And if it's an error, then it will map, oh, by the way, I also always like to look at the examples to understand what's going on. And if it's an error, then it will actually use this function that we define here. So for instance, here we will get again our error code, and we could do something with it. So maps a result to a result by applying the function to the contained error value, leaving the okay value untouched. So with this, we can, for instance, handle the error. So before we unwrap or else, we could say map the error code, and here basically, for instance, just print this error has occurred. And then I could return 0. Is that getting confusing again? So first I take the error code, I print the error code, and then I map it to a new error with 0 now. And then this will be, here I get the code from what I created here. So this code is now a I32, and I'll make it a U32. So I could also make that a U32. Quick typing. Then I get the U32 in here. And maybe that's not the code anymore now, maybe that's something else, some other error, because I've mapped it. But yeah, then the result should be 0. But we have printed this thing before because we had that error. And if we wouldn't have an error, then we wouldn't get to that part where we print it, obviously, because the map error will skip that function if it's okay, because we just mapped the error to a different error. And one last thing, because that's also something that comes up a lot. And while we're talking about results, that's where it's most often used. let's say I'm in this function that returns a result, and here I call another function that returns a result, or maybe even call my own function 1 plus 2. Let's say I wanted to do something like inner result, and if inner result is error, then I return inner result. Function cannot return without recursing. A loop may express intention better. Don't be smart, Rust. I'm trying to make a point here. So if I get an error here, then I want to return the inner result, and otherwise I go with that. And to actually, if I don't have an error, oh, Stack Overflow. Wait, why am I never breaking? Oh, because I'm constantly recursing. Yeah. Just want to do it once. How do I do it once? No, I don't want to make it too complicated. I just do another function for you to get it. I mean, I could do if no brackets, argument 1, not 1, and then do this. Which, you know, is ugly, but it's one way to break this recursion because I have the 1 here and the 1. But yeah, then it would be fine. And let's make this error by having a larger number here. So now I'm erroring with this inner result that I got from the recursion here. This is really a way too complicated example. I need to be more precise. Hold on. Scratch that. New idea. Let's do a function that returns a result. And in fact, it will return 99. Error code 99. That's all it does. Oops, it returns that. So let's not make this too complicated here. I call that function that returns a result. And this will in fact return an error, we know, but here we just know it's a result. So if it's an error, I want to return the inner result. Okay, then we will have this error occurred 99 here, right? Because that's the error that if we get it, then we return it. Otherwise, if we don't get that error, we would continue with regular execution. Let okay value be inner result unwrap. There you go. When we return the inner result on error, we can be sure that here we can safely unwrap because we have the okay value. So that, however, there's a much nicer way to write this. And that is, instead of all of that, I just call my function and say question mark. And then say, let the okay value be this. That one line is the exact same as this part, just, you know, way more compact. So what does it do? The question mark will check that result. If it's okay, then unwrap it and give you the value. That's why we get the U32. And if it's an error, then it will basically return that exact error. And here that only works because that result type is the same as that result type. Or more specifically, it's not about the result type, it's about the error type. So this error type must be the same as this error type. If I had a different error type here, I don't know, if this was a U64, because I just like to play with numbers. In real situations, you will have actual types, like Solana program error, for instance, as a error type here. But fine, I just use U64. Then this will complain because it expects a U8 here and not a U64. But what can we do? We already learned that. Well, we'll just map the error and we get the U64 code and we map it as a U8. Basically saying, trust me, bro, just take it as a U8. And there's a safe way to do this as well, which would be a try into. But then since we try that, we get a result, and that again, we would need to unwrap if it doesn't work. And that way, if I map it to a U8 again, then this will be happy, so I can question mark. That's this question mark that also comes up quite a bunch. This way you can write convenient things, always being like a function that returns a result, question mark, and then just work with the value. And whenever an error occurs because of the question mark, it's pushed up there. Yeah, so that also works. Good. There's so much more that we can talk about though. But let's finally get to the borrow checker. Right. Rust has a pretty nice way of dealing with memory and freeing up memory. Other languages like Java have a garbage collector, but that's inefficient. So let's say you have a, I don't know, simplest thing is probably a string. Let's say I have a string to string. I want an actual string, an owned one. I can work with this, no problem. I can print it, I I could return it, but this function doesn't return, so can print it, no problem. I can put it in another function that takes a string and prints it. There. That will work. It's printed twice. Yeah. So far so good. But check out what happens when I first call the other function to print it. Then suddenly it's red and you're like, wait, what? It's just doing the same thing but in the other order. How is that? Like, the string is still here. It's that what's going on here? Well, my friend, welcome to the borrow checker. Consider cloning the value is the suggestion that Rust has. For what is the actual error? Borrow of moved value my string. Here the value was moved and here it's being borrowed. What's happening here? Well, Rust has this concept of ownership, where all the objects, or the string in this case, are owned by exactly one variable. In this case, by this my string. And they can only ever be owned by one. And that is done such that when that disappears, they know that the storage can be freed. And when I now want to use that in another function here, then I give the ownership to this one. Now this string variable owns the actual string. And once that returns, the validity of this goes away. Basically, string now doesn't exist. And Rust is like, okay, at that point, I can free it. It's not used anymore. If I want to keep using it, I could return the string here again. And then basically I would have to do something like this and make this mutable and tell it to return a string again. Then it would work. So basically I would put it in here, put it in that function, and then it returns it and it comes back out and I can take ownership of it again. This would work. Here that would work. But it's not a particularly nice solution. Also not a particularly nice solution is to clone the entire string. I mean, I basically make another copy of the string. That would also work because then it's a new string, but it's a different thing, right? Because I'm basically copying it. This is not particularly efficient. Another way how to deal with this, instead of working with the actual owned string here, so the capital string, I can work on a reference. So a reference of a string. And I can basically say, here, you can have a reference to this string. That means the function can work with it, but it doesn't get ownership. And this way it will also print both of them. You've probably worked with references in C or Java or wherever you've been working. Does TypeScript do references? Pointers? I'm just gonna assume that you know what a reference is. Basically just pointing to the storage. In this case, this string, this variable called string, let's call it string reference, points to where the actual string lives. And I could even be like, let it point to a specific part of the string, just the B, C, D, E, F. So from 1 to the end. Or if I want C, D, E, I start from 2 to 5. Then it just points to this part of the string. Or I let it point to the entire string. It's also called a slice. Basically, those references, you know, they reference a continuous part of something. I can have a slice of U8s, right? If I have let U8s be 1, 2, 3, 4, 5. Say those are 5 U8s. And then I can do the same and have U8s, a slice from, I don't know, 1 to 3. And that would point to those. No, wait, 1 to 3, those. Prove it. There. So that would be a slice of U8s. And you always say beginning, and that would be the entire thing again. And that's a slice. So we have a reference to this. It's not owned. Here it's owned. This variable basically owns that thing, but here we just have a reference. Okay, good. Just that also works with other things, not just, you know, strings, characters within a string. But let's stay with a string example. Forget that. I can work with a reference And references, I can have several, right? I can have kind of one reference to the entire string, one reference to just skipping the first one, just ABC. How about that? So I can have several references to the same string. That works just fine. But I can only own the string once. And whenever I call a function or put that string somewhere that requires the ownership of it, then I lose the ownership. If I have a function taking ownership of the string that again takes the owned string, that I can only do once. And at that point, it's then gone. I will need to do this at the very end because this one will then drop it. It will just take it and delete it. By the way, what I'm doing here is the same as if I would say drop my string. I have already dropped it here. That function does exactly the same. It takes ownership of it and then destroys it. That's the literal implementation of it. So yeah, my point here being, you just need to be aware of who owns each of your objects or strings or variable. If it has a copy trait like all of the primitive types do, integers for instance, then it's fine. Or like also references, they can be copied. So that would be fine. Let integer, then I call that function on it. I call that function on it again and again. That's fine because that's always just copied there. But strings or things of other types that do not have the copy trait, they will not be copied. They will put in and ownership will be taken. And then you will be confused as to why you can suddenly not work with this thing anymore. That's probably the most difficult part to get behind when starting out in Rust development, is to understanding this concept of this borrow checker and the ownership concept. Basically saying you just can't do that. You need to structure your program differently to not lose ownership of this string or make a copy of it, right? If I make a copy of it here, I'm fine. Just clone this, everything is fine. And for strings, a little bit of cloning is okay, but some stuff you can't clone. What do you do then? Use references, like we did here. Yeah, so if we lose ownership, we want to lose ownership at the very end before we also don't need it anymore. And that's just a quick little intro. I think I'm good with that. Maybe give you more pointers because there's so much more that we haven't talked about, like lifetimes or unsafe Rust or other types like vectors and stuff, the standard library. Like you will not learn Rust in a day unless you're really good, but not in one video of mine. But what I can recommend is this Rust book, rustlang.org/book. where you will find chapters to all of what we've talked about, like what is ownership? That's how a Rust program manages memory. Each value in Rust has an owner. There can only be one owner at a time. When the owner goes out of scope, the value will be dropped. That's basically the rules that it goes by. So yeah, you can read up more here if you want to dive deeper, looking through references and stuff. I like the book. The book is good. The slice type, talked about it a little bit. Iterators and stuff. We haven't talked about that. But yeah, anonymous functions. That's what it's called. I like this. Look. Same. Yeah, so there are great examples in here. Can go through those. We didn't go through threading, but that's also not really important for Solana devs. At least not for on-chain programs because that's not possible there. Unsafe Rust. Haven't talked about that. But if you're a beginner, you probably don't want to use unsafe Rust. That's just for if you really know what you're doing. Macros. We haven't talked about macros. Macros are a way of writing code that writes other code, which is known as metaprogramming. That's what, for instance, the entry point does. It writes code for us. But yeah, that's more advanced topics. I will let you go through that by yourself. We said this is a basics video. And with the basics, we stay. So I hope that gave you a good introduction to Rust, especially when you come from other languages. Just a quick, here are some things that you should know to understand Rust. Let me know how well I did and what are the things that you still want more of a deep dive on. I can do deep dive Rust videos as well. I can certainly do an entire video on the borrow checker and the nuances there, but I wanted to just give you a quick little intro in case you need it, which if you watched this far, you probably did, which is nice. So I didn't make this video for nothing. So thanks for watching. Now that you know how Rust works, there are some other videos that teach you how to program on Solana. And yeah, stick around for more Solana content. Like this video, subscribe if you haven't done that yet, and I will see you another time learning Rust to develop on Solana. Because there's no real way to get around Rust if you want to be a Solana dev. And that might just be my opinion. But you don't need to be a Solana dev to learn Rust. So, I mean, yeah, if you're here for non-Solana stuff, great. Also works for me. You do you. I hope this video was helpful in any case. And I might or might not see you in the next one.